everyone, my name is David and today I'm gonna record this video. Let's start. Fever feels bad, so we take medication to suppress it. But is this a good idea? It turns out fever is one of the oldest defenses against disease. What exactly is it? How does it turns our immune defense stronger, and should you take a pill to combat it? The heat of life. On Earth, life is thrived between extreme temperatures of 10 Celsius degrees and deep cool pools and 100 Celsius degree in thermal vents. Stabilize the strange and die. Every animal or microbe has a temperature range that is ideal and one of that is stressful but survivable for a while. Your ideal temperature is where your cells work best, where your essential machinery is most efficient, and the animals is whole best adapt to its niche. Humans are warm-blooded animals, and our body expend a lot of energies to keep us around 37 Celsius. Or 98.6 Fahrenheit, which seems graceful, but may actually be a defensive action. Our temperature makes us also entirely immune to one of the worst killers and parasites, fungi. Most colder animals and they're infected by them. But you are just too hot. Which brings us to fever. For a microwolf that they want to infect you, your body is a world that they want to conquer. Fever is a defensive climate change, pushing invader outside its ideal temperature range and making the world horrible. It evolved at least 600 million years ago, and it's widespread. Most animals increase their core temperature when they're sick. Fish swim into warmer waters. Lizards bathe in the sun. Bees heat up their air in their hive. But you, warm-blooded mammal, you have way more dramatic options. Let's make you sick and see what happens. When your blood turns into lava, you're invaded by bacteria and viruses at the same time. The invasion is powerful and you need to slow it down as fast as possible. Fever is part of your first line of defense, triggered by a diverse group of chemicals called pyrogens. The creative heat, they float away from the battlefield and passes right into your brain. When the specialized receptor pick up and crank up their internal thermostat, first you begin to shiver. Your skeletal muscles contract really quickly, which generates a lot of heat in your core. At the same time, usually the blood vessels near your surfaces contract and prevent heat from escaping through your skin. Your skin cools down while your inside burns. Fever is a systemic, body-wide response and a serious energy investment for your body. You burn about 10% more calories to stay alive for every degree and body temperature rises. Fever is also a strong order to lay down and rest, to save energy and give your immune system time to fight. Back to the battlefield. When the bacteria entered your body, they tried to be stealthy, but now they switch into high production mode. The goal is to multiply as fast as possible, which means they need a lot of resources and are highly stressed. Imagine running a marathon while eating succulent Chinese meal and giving birth. The last thing bacteria need now is more stress. So immune system tries to stress them out as much as possible by ordering inflammation, which floods the battlefield with fluids, attacking proteins and shoulders. Pretty stressful. Fever is even more stress. For bacteria, a moment ago the temperature range was pleasant. Now the word burns. Heat can cause the organs to break and membranes to rupture, damage their DNA and diminishing protein production. They are seriously suffering from the heat. Why does this affect your cells? It does. All of this is stressful for yourselves too. Virtually every system and organs in your body works worse during fever, except one: your immune system. Neutrophils are created faster, macrophages and direct cells are better at devouring enemies, killer cells kill better, and so on. And fever animates your immune cells to gobble up and the critical resources your cells need, like iron, glucose, and glutamine, turning to battlefield into a food desert. Viruses that infect millions of cells are doing even worse because they are also sensitive to heat. For example, the rhinovirus is caused the common cold that only can affect your respiratory tract because it's significantly colder than the rest of your body, even without fever. The heat is also really bad for millions of cells that are infected by viruses. At this point, they are working super hard and producing viruses, which is pretty stressful. As the heat becomes too much to bear, the super stressed cell panicked as their internal machinery is breaking and falling quickly, producing billions of heat shock proteins of HSP, keeping them alive. But this is a trap. Your healthy cells produce HSPs to deal with the heat, but if a cell makes too much of them, it means it's more stressed than it should be. And if it's too stressed, something's wrong and it should be killed. So your natural killer cells and killer T cells are activated and attracted by HSPs and start killing infected cells and all the viruses inside them. By trying to protect themselves, infected cells are calling out to be destroyed. But if fever is such an effective weapon, why won't your enemies adapt to it? How is it still valuable in so many different animals? After 100 millions of years, a wild reason is that fever actually outsmarted evolution. If your enemies survive fever long enough, natural selection changes them. Individuals that are better suited to deal with heat reproduces more. After a few days, they've adapted. But this thing becomes a handicap because the next step is to infect new victims in new bodies, and now healthy humans are too cold for them. Not impossible to infect, just harder, and the heat-resistant microbes are now compete against their cousins that like it colder with an advantage of infecting healthy hosts. This creates an evolutionary dilemma without a perfect solution. To circumvent this, serious pathogens like measles use to hit and run tactics. The measles virus plays ultra fast and is the most infectious right before your fever hits it. But then the damage is done. It's brutally beating up. Fever is an effective part of the puzzle of your immune system, helping attack and stress your enemies from many angles possible. But if fever is so great, why do we stop it when we're sick? Should you fight fever with medications? We think it's normal to have magic pills, relatively harmless. Over-the-counter pain medication like aspirin, ibuprofen became cheap and widely available in the last century or so. Going to a pharmacy to get something for your headache is extremely new in human history. Pain feels bad, so we got used to stopping when we feel it. If you're sick, you're supposed to feel a reasonable amount of pain, so you lie down and save energy. This is not a bug, but a feature of your immune system. But pain and fever are closely connected. And over-counter pain medicine like ibuprofen and paracetamol also works against fever. Especially in children, fever is most suppressed by worried parents or doctors, sometimes because they think the fever itself is a disease and worry it can do long-term harm. It's general to fair to say that for temperatures below 46 degrees, fever it's not dangerous. And of course it doesn't need to be treated. Of course, there's also patients that should not have fever, like pregnant women, seniors, and seriously weakened patients. For them, extra stress may be dangerous. Fever over 40 Celsius is dangerous to anyone because it's most likely caused by your essential heat moderately falling. This thing gets more complicated in serious disease territory. We also have evidence that for diseases like influenza or chickenpox, anti-fever drugs do not help you heal faster. But we also run into ethical problems that make clinical trials difficult. In one study, doctors gave a strong anti-fever treatment to critical care patients, but had to stop when mortally shot up. Overall, we have strong indications that more people may survive a serious infectious disease better with a fever. And there's little clinical evidence that stop fever leads to better health outcomes. But there's important exception. Our neurological injuries and stroke. We definitely need more research. So, should you fight fever? Well, speak to your doctor and don't listen to internet videos. But this decision is really about payoffs. If a fever is not dangerously high and you can bear it, you're supporting your defense and may get healthy a bit faster. But if you're feeling really bad and you're healthy in general, taking a pill against pain and fever will make it feel better quicker. The cause of slightly less effective immune defense. However, you decide the next time you're burning up and feeling bad, you can rest easy and in the knowledge that your enemies are having much worse time than you. So that is the end of the recording, and bye.